Okay. Hello, everyone. Thank you for joining. My name is Magno Logan, and I'll talk about Kubernetes security, attacking and defending Kubernetes clusters. I'll be available during the talk to answer any questions via the chat. Okay, so let's start. Just a little bit about myself. I work as an information security specialist for Trend Micro in the cloud and container security research team. I'm also part of the CNCF SIG-Security team, and I don't consider myself a Kubernetes security expert. I'm still learning, but I'm gonna share with you what I've learned from the past year about studying Kubernetes security. This is the agenda for this talk. We'll try to cover all the topics in this 35 minutes talk, but that's why I want to talk about these topics right now, and we'll go right into them. Just before we start, I just want to highlight this awesome Kubernetes security list project that I created on GitHub. There's the link there, and it has a lot of content and tools, videos, and papers, and everything that you can could use to learn about more about Kubernetes security. So feel free to check it out. Okay, so what is Kubernetes, right? Just to give you an overview, if you don't know yet, but Kubernetes is an orchestration, container orchestration solution, right? It's basically an open source system for automating deployment, scaling, and management of containerized applications, right? So basically containers. And it was originally developed by Google and released in 2014. And today it is maintained by the Cloud Native Computing Foundation. Okay, so this shows here on a high level the Kubernetes architecture. And we can see that we have two major components here. We have the control plane on the left side and the worker nodes on the right side. So we have 3 worker nodes on this diagram here. Basically, you have 5 major components on the control plane side on the left side here. So you have the Kube API server, which handles exposing and receiving API calls, right? You have the etcd database, where Kubernetes stores all its internal information. You also have the kube scheduler, who decides where to run the pods. On the top left corner there, you have the kube controller manager, which is responsible for several internal tasks in the cluster, noticing when a pod does not respond and maintaining the correct number of pods, etc. And also on the you have the cloud controller manager there, which interacts with cloud providers, managing resources such as load balancer and disk volumes. Okay. On the right side, on the worker nodes, you have the kubelet, which is responsible for managing the container runtime by executing containers when necessary and collecting execution information, right? You have the kube proxy, which manages network communication, allowing different containers to communicate between each other. Also responsible for external requests. Excuse me. And you also have the container runtime, right? Which is the one that creates and executes the container themselves. By default, it was Docker, but now that's being deprecated since Docker Shim is being deprecated. But you can use either containerd, cryo, or podman to run your container as your container runtime engine. Okay. And just before we start, just a quick note here. On Kubernetes, you don't deploy containers, you deploy pods, right? So pod is the smallest unit that you have in Kubernetes. It's the smallest deployment unit, and it can contain 1 or more containers. So for example, I can have a pod that with 2 containers. One is the main container, and the other one is the sidecar, which collects logs and metrics and other information, right? Okay, that's good. Okay, so moving on. So today we're going to talk about attacking and defending clusters, right? So we need to talk about Mitre attack framework, which is basically a framework for development of specific threat models and methodologies in many different sectors, right? So it's just basically a globally accessible knowledge base of opposing tactics and techniques based on real world scenarios, right? And it was developed by Mitre. And we're gonna see here firsthand the new Mitre attack framework that was published last week. For the first draft was published last week, right? But before we go into that, so Microsoft created their own version of their Mitre attack framework, which is they call it the K8s Kubernetes threat matrix, right? By Microsoft Azure. They released that last year in April. And has a lot of good information there, and some tactics and techniques that we can see, and highlighted here are the ones that we're gonna demonstrate today in our scenario, right? But this is not an official Mitre attack framework. This was just released by Microsoft, but it was very helpful and used as a baseline to create the original, the official version of the attack for containers and Kubernetes as well, which was released last week, as I said, February 18th by Mitre, and we've collaborated with them and helped them based on the real world scenarios that we've seen in the wild based on our research and our honeypots and everything. And so it's nice to showcase here that this is being developed. This is the first draft, and it's always it's going to be improved, and it needs feedback from the community. So if you have any data or information about other real world scenarios, feel free to reach out to me or check out the blog post by Mitre and reach out to them directly. So this is the attack scenario that I created based on the Microsoft one, because Mitre wasn't released yet, right? So basically here I'm describing an attack scenario that a malicious user or an attacker would do to compromise a Kubernetes cluster, right? So basically, I won't go into all the details here about this diagram, but basically you have a web application that's running and it's exposed to the internet, and this web application is running inside a pod, which is inside a Kubernetes cluster, and it's exposed to the internet, and it has a vulnerability there. It has a vulnerability of remote command execution vulnerability, right? So an RCE, which when exploited, the attacker is able to get a shell inside the pod in this case, right? And then from there he can do he or she can do in either like lateral movement, just some basic internal recon, privilege escalation, and from there compromise either the whole cluster or even the cloud environment if it's running on a cloud provider as well, right? So one of the most common things that we see when attacking Kubernetes and Docker as well, we have a lot of articles published on this topic, is that the attackers usually try to automate the scanning phase and identifying open or vulnerable clusters or API servers. And basically when they exploit those environments, either via a vulnerable web application or an exposed dashboard or exposed API server, they try to compromise and the cluster and spin up containers to mine cryptocurrencies, right? So either they spin up containers on the cluster, or they try to, if they can have permissions to do so, they try to spin up new instances, bigger instances on your cloud environment to mine cryptocurrencies, usually Monero cryptocurrencies, right? So just a quick note here. So while doing this experiment and testing, basically I used this vulnerable Drupal version of a web application, right? It's a CMS web application, excuse me. And so we exposed that to the internet via a load balancer on the cluster. And this application has well-known RC, which is the 2018 7600 CV, the Drupal Gaddon 2. And just basically in less than 24 hours, they were able, like the attackers were able to find that URL and compromise it by mining cryptocurrency as well, right? So just while doing the experiment, and we also have seen that happen oftentimes on our honeypots as well. So how do you find that, right? So how do you exploit? How do you identify that a web application is running on a Kubernetes environment, right? So one of the first things that you can do, if it's running on managed services like EKS, GKE, or AKS, right? Basically, if you can find out the URL of the load balancer, that might tell you that's a Kubernetes cluster, and you're gonna see that by the URL on the next line, right? Another thing here is exposed dashboards. So Kubernetes had a dashboard enabled by default, which before a few versions ago was enabled and didn't have proper authentication. Another issue is with the Kube API server, where if that is exposed and it hasn't, it doesn't have the proper configurations, then you can reach out to the API server, sometimes even without authentication, right? So by exploiting this vulnerability here, the CVE, we get a shell inside inside the cluster, inside the pod, right? Okay, so right, I'm able to reach the API endpoint externally. Here are some examples. By default, on an unmanaged cluster, Kubernetes uses the port 6443 for the API server, and on managed services, sometimes is the port 443 by default, right? And you can see here that by the URL, you can see that that's using EKS on Amazon AWS on the second URL, right? So that's easy to know that the applications running here are using a Kubernetes cluster, right? So so that's one of the ways to find out about that, where the application is running. And after you exploit this vulnerability, you get a shell inside one of the pods, either via an exposed dashboard or an RCE, right? Just a quick note here. I think Tesla was hacked a few years ago, 2018, because of exposed Kubernetes dashboard, where the attackers found that dashboard URL. And from that dashboard, they had permissions to deploy new pods and compromised the cluster environment. They deployed the pods to mine Bitcoins, cryptocurrencies, right? So usually Monero. And they basically did that, and Tesla got a very expensive bill on their cloud account, right? Okay, so that's one of the things that we can do. Another tool that's interesting to use is CubeHunter. CubeHunter hunts for security weaknesses in Kubernetes cluster. It was developed to increase the awareness and visibility for security issues in Kubernetes environments, right? And it currently detects 37 vulnerabilities on a Kubernetes cluster. I think it's developed in Python, and it's open source, right? You can contribute to the project as well. Okay, so I'm inside the cluster. I got a shell inside a pod there. What can I do, right? So one other things that you can do, it's an internal, we call internal recon, right? So, okay, I'm inside the pod. How do I know that I'm inside a container? I'm inside a Kubernetes environment. If I didn't have the proper URL that would flag that to me, right? So one of the first things that you can check are is the environment variables, right? So by typing that command there, you can see if there are environment variables related to Kubernetes. So that might show the Kubernetes API server, the ports and everything, right? So you can see that from inside the pod. You also have the service account token, which every pod on the cluster has, right? Which they use this token that's inside that, that directory there to communicate with the API server, right? So to perform the authentication and communicate to the API server. So you can use that to impersonate the pod and make requests to the API server as well. So kind of authenticated requests. So you might have more permissions and get more information out of the API server, right? Another tool is the AMI container tool, which is called container introspection tool. You can find out what container runtime is being used, as well as features available there. So that's also going to show if you're running inside a Kubernetes cluster or in a Docker environment as well, right? Other things that you can do, right? Basically, usually the name of the host name of the pod or the container are specific, or they have some suffixes at the end that might give away that that's running in a container environment, containerized environment, right? And other things are the number of processes, right, that's running also on the environment. You can check. Usually the container has a few processes, usually one, right? So, and that's not the case for a virtual machine or bare metal environment, right? So, okay, I got I did my internal recon. I found some information there. I identified that I have permissions to exploit this cluster. I have permissions to create a new pod on this cluster, right? That's great, right? So now we go to the privilege escalation phase, right? And one way to do that is by performing like a pod or container escape via a privilege pod, right? So here's a technique posted by Duffy Cooley from VMware on 2019, where we're creating a pod, a privilege pod here, but it has some override or arguments. As you can see there, has a JSON to overload the spec with partial set of values parts from the JSON, right? So just a quick overview here. On the right side, I have the JSON formatted better for visualization. So basically, first here we see the host PID set to true, right? So which breaks the most fundamental isolation of containers, letting us see all the processes as if we're there, as if we were on the host, right? We have the endcenter here command, which is used to switch to different mount namespace, right? And since that's guaranteed to be the host mount namespace, right? And the privilege security context here at the end is necessary to prevent any permission errors when accessing that that path here on the mount, right? So this was also used on a workshop from KubeCon 2019. The source is securekubernetes.com. So just make sure you check that out. That's very interesting learning about Kubernetes attacks there. Okay, so let's go to the defense part, right? So defending Kubernetes, like how can I protect my cluster from attackers? Isn't Kubernetes secure by default, right? So where do I start? So the first thing here is protecting your API server, right? So make sure that's not exposed to the internet and accessible by attackers, right? So if I get, if I just make a curl request here to my API server, I get this response. Although that gives me a 403, like a forbidden, since I don't have permissions, I didn't pass any authentication tokens, right? This already shows me that this is a Kubernetes cluster that's running there, right? So this is the default one. So if someone can reach out to your cluster like that, that's already an issue, right? So that should be limited through either like a VPN or firewalls or security groups that only allow your developers and your employees from your organization to access that cluster, even make this simple request, right? Okay. So one of the first things that you can do to protect your cluster is also checking the CIS Kubernetes Benchmark, right? So the Kubernetes Benchmark is a prescriptive guidance for establishing a secure configuration posture on for Kubernetes, right? It has over 120 security checks for your cluster, right? It was created by Rory McCune and Release Rice and many other contributors as well. And there are specific ones for EKS and GKE. So there's a lot of information there. It's currently on version 1.6.0, which was released on July 2020. And it covers the Kubernetes cluster versions from 1.16 to 1.18. Okay, but how I'm gonna do that like manually, right? So if you take a look at the benchmark, it's a lot of pages, a lot of checks that you have to perform, and it's hard, especially if you have multiple clusters, right, on your environment. That's gonna be hard for you to check one by one, right? So there is this open source tool that was released by Aqua Security as well called Cubebench. They basically check whether Kubernetes is deployed security, validating it against the CIS Kubernetes benchmark. It's developed in Go, and it basically checks all the items from the benchmark and gives you a pass, fail, or warning response. So as you can see here, this is just one of the results, and you can see that my cluster is not very well configured with a lot of issues there, or it wasn't able to detect that if it doesn't have the permissions. But you can see that the master node, it checks the API server at CD, the worker nodes, and other configurations as well. So I recommend you to take a look. Okay. One of the other things that you can do, right, before you deploy your cluster and your container images, right, is do what we call image scanning, right? There are many tools out there to perform that for you. So basically, you check your container image for known vulnerabilities, malware, misconfiguration issues, and other set of like permission issues that may cause problem if your container is compromised. Some of the tools here that you can use are Claire, Smart Check, Sneak, and Trivi, right? And also there's now there's a scan command that you can basically run if you're using Docker. You can run the Docker scan command, which under the hood uses the Sneak database to check for vulnerabilities and on your container image and dependencies there as well. So I recommend you to check that out. Okay, you check the images, you scan them, they look fine. You did the CIS Kubernetes benchmark, everything looks good. But now you've deployed your cluster running, and it's in production, right? So how do you know that your containers are not have not been compromised and are not doing something funny, right? Like having an open SSH running there, or executing some files, or changing the state of the container image after it is deployed, right? So which something that's a technique that's called drift detection, right? So there's this tool called Falco, which was developed by SysDig in 2016, and now belongs to the Kubernetes, the Container Cloud Native Computing Foundation, right? Which is basically a cloud native runtime security project, right? Or as they call it, the de facto Kubernetes threat detection engine, right? It's an incubation level project. It detects unexpected application behavior and alerts on threats at runtime, right? So basically, it parses Linux kernel syscalls at runtime, and based on some rules engine, easy like a YAML file rules engine that's easy to read and to create. That rules engine detects the unexpected behavior in a cluster and generate alerts based on these threats. And you can integrate that with other tools as well. So I recommend that you check that out. Okay, that's good. And what are the things, right? What are some basic stuff that you can also do on your cluster without needing third-party tools to protect yourself, right? So basically, you have the pods, right? As I said, pods is the smallest deployment unit on the Kubernetes cluster, right? And so just like containers, you have to limit the resources, the CPU and memory, otherwise the pods can start consuming all the resources available on your node and leaving the other pods with performance issues, right? And possibly causing a denial of service on the node. So the way to fix that is either setting the limiting resources, the CPU and memory sources, specifically on the container, on the pod spec, right, on the YAML file, or you can use this resource quota that applies that configuration to all the pods on your cluster. Okay, one other thing is creating and applying a security context, right? So you can, there are some privilege and access control permissions that you can set on a pod. Here are just a few examples that you should enable that on all your containers to avoid any privilege escalation issues, any issues with writing to the root file system, or running the container's root, right? Which is also a big issue there. Also, there are some Linux kernel security features that you can enable. Some of them here are SecOps, AppArmor, and SE Linux that also protects your container and your cluster against some attacks, right? Okay, moving on. There is something called admission controller, which is a piece of code that intercepts requests to the Kubernetes API server prior to the persistence of this object on etcd, right? But after the request is authenticated and authorized. One of these admission controllers is called the Pod Security Policy, or PSP for short, right? And it basically has it can control most of the security settings mentioned before on the security context, but now on a cluster level, right? Unfortunately, this PSP will be deprecated on the next version of Kubernetes, the 1.21, and will be removed on version 1.25 probably next year. So what can you do there, right? There are some alternatives that you can use to other CNCF tools are the OPA Gatekeeper and Kyverno that you can use some policy controller for Kubernetes as OPA Gatekeeper, or Kyverno is the policy engine designed for Kubernetes as well, right, that you can use. Other options that are still in discussion by the Kubernetes SIG-Off team are two new implementations of the pod security policy. One is called the PSP++, or the container boundary policy, and the bare minimum PSP, which is intended to capture more common use cases and provide a baseline security. So I linked those documents there. They are still in discussion. They are not official and they're not implemented yet. But I think it's important for you to be aware, since that might be an option for you to replace PSP in the future. Okay, yeah, okay, let's see. You've secured your cluster, you protected, you've implemented some of these tools already, right? So, but now you're considering like an insider threat, right? So there's some employee that has permissions to your cluster, and they might have too much permissions and compromise or do something that's harmful to your cluster, either intentionally or unintentionally, right? So on Kubernetes, you have RBAC, which is called a role-based access control. It's basically very similar to access control on most web applications, right? By role, you have like, you can have the cluster admin, you can create new roles and permissions for each of those roles, right? Now it's enabled by default on the latest Kubernetes version. You can check that by checking that that setting authorization mode on your Kube API server. And basically what RBAC does, it has 4 different objects: row binding, cluster row, and cluster row binding, right? And those objects basically contain rules that represent a set of permissions within a namespace. So row is restricted to the namespace level, right? And row binding basically binds these permissions from the row to one or more users, right? So a set of users. And the other 2 objects there, cluster row and cluster row binding, are basically the same thing, but they're not tied to a namespace, and it will be applied to the cluster level. So all the namespaces on the cluster, and so they are more permissive, so be careful with that. etcd, as I mentioned before, is the main data storage for your cluster, right? All the cluster objects are saved here. And we've identified that there are 2,600 exposed etcd on Shodan today, right? So recently, this is a recent search. And just be aware of that if your etcd is exposed, it also has an API that you can interact with. And if an attacker has access to the etcd, they basically can do anything on your cluster, right? If they have write access, they can create objects, delete pods, or anything else, right? Because Kubernetes is always checking etcd to maintain that desired state, which reflects what's in etcd should reflect what's in the cluster, right? So 2 quick things here about etcd. Basically, the encryption in transit is done by default. You can check that by running this command here and checking those files, the certification file and the key file, right? But the encryption at rest is not by default, right? So it's not done by default. Everything in etcd is stored by in plain text, including your secrets, right? Which is an object that is usually used by Kubernetes to store sensitive information, right? So to fix that, you have to create an encryption configuration object that you select what should be encrypted on your etcd, and that will be encrypted at rest as well. But that's not done by default, so be aware of that. And for network policy, also by default, all pods can communicate with any other pod in the cluster. So basically, that's a flat network. And if you have a network background, you know that's not a good thing, right? So make sure that you create a proper network policy for your cluster, right? So like ask questions like, does the front end really need to talk to the database pod, right? So what if an attacker can access the pods on the kube system namespace, which is the main namespace for the Kubernetes cluster, where the control plane pods are usually running, right? So Cilium, which is a network, a CNI for Kubernetes, right? Network interface. we just released recently a network policy editor, and that's very nice that you can visualize who can access what on your cluster, and then they already give you the code, the YAML file for the configuration that you set there for your network policy, right? So that's nice to check it out. The link is there in the slides. And just to finalize here, another thing that's important for Kubernetes to Kubernetes security for protecting your cluster, right, is the Kubernetes audit logs. They are not enabled by default, right? So it's highly recommended that you enable them for security and also for troubleshooting, right? You basically need two things for enabling them: a log path and a policy file, right? So specifying where the location of the log and which policy, so what you want to log. So there are some policies you can log just the request or the request and response or just the metadata, right? And you set those up on the Kube API server configuration, right? If you're running on a managed services, basically, for example, an EKS, it's just a click of a button to enable those logs on AWS, and they go to CloudWatch. And to finalize here, the basic stuff of protecting your cluster, right? So don't forget about those. Those are also important. So update your Kubernetes environment version early and often, right? The latest version is 120, and Kubernetes usually updates their version at least 2 to 3 times a year, so almost every quarter. So be aware of that. Don't use cluster admin for daily work. So treat it like a root user on your system, right? If you can, use the managed Kubernetes service like AKS from Azure, EKS from AWS, or GKE from GCP, because they handle the master node for you, so you don't need to worry about the security of the control plane and Kube API server and all that stuff. Just be aware of their default settings. For example, like EKS, which has the Kube API server URL exposed, publicly exposed by default. And check the CIS Kubernetes Benchmark document for more security best practices. They're always updating that to cover the latest version of Kubernetes, so I think it's important to take a look. And with that, I conclude my presentation, and I'm gonna be answering questions on the chat. Okay, thank you.